individually. Okay. Now we proceed with the open method. Oh, someone already recorded. Okay. Okay, we proceed with the open method. Last time in bracket, you are given 2 points, lower range and upper range. Okay, that one is bracket. Okay, for open method, you will be only given 1 point as you're starting to for you to start your calculation. Okay, only 1 point. So there are, for open method, we have fixed point, Newton-Raphson, secant method. We will go one by one. Fixed point iteration means you will be given an equation. So you will need to rearrange the equation. If in bracketing, let's say you are given fx, x, this one. So you have to make sure fx is equals to 0. Okay, from the exercise that we had done, some of the question, it gives you the infos on the fx. Okay, for example, fx is given as 4, then x2 minus 1. So you have to rearrange so that y, fx equals to 0. Okay, this one is bracket method. For open method, you will need to rearrange so that you get x equals to something. X equals to fx. Okay, we go in detail. Okay, in fixed point, we rearrange the function fx equals to 0 so that x is on the left-hand side. Okay, x on the left-hand side equals to fx or gx or y. Okay, now for example, we have this equation. This is your fx. Now this one in bracket method last time, this is the equation that we are looking for, fx equal to 0. Okay, now in open method, you have to rearrange the equation so that you get x equals to this side. So x equals to fx. Okay, so fixed point iteration, you should rearrange in order to get x equals to fx. Okay, up to there. So in this equation, rearrange until you get x equals to fx. So this is the one that you will be using in your calculation. Okay, this equation. Similar to if you have sin x equals to 0, so rearrange it until you get x equals to fx. Okay. Now the formula can be used to predict a new value of fx. Sorry, a new value of x as a function of an old value of x. So why you need to rearrange? Because we want to find the new value of the x. using the old value of the x. So from here, let's say this equation, so this is to find x new. This x is the old value. X old means x previous. Okay, because you will need to do iteration as well for this method. Okay, you can use either x new or xi plus 1. Either term, we will need to find the new value of x. Okay, using the previous value of x. Now, EA, you should be familiar with this equation by now. Current minus previous over current. This one is EA. Okay, how about ET? True error. Correct. If ET, you will need the true value minus approximate over true. Okay, true value later on, you will need to calculate using the calculator. That is your true value. Okay, now we try to do this exercise where it use simple fixed point iteration to locate the root. Again, the root is xr when y equals to 0, fx equal to 0. Okay, so it gives you this equation. Use an initial guess of x naught 0.5. Okay, it gives you a starting point, only one value. In open method, it will give you only one value for you to start your iteration. Okay, and it asks you to iterate until EA lesser than 0.01%. Now, first thing first, we need to rearrange the equation in order to get x equals to fx. From equation given over here, okay, we rearrange. So you will get x equals to sine x. Okay, up to that? Okay. This one you rearrange to form this. So this x is the new x. X new. This one will be x old. Okay. Or I plus 1, I. Okay. Either term. Either you want to use I or new old. Okay. Now start your iteration with 0.5. This given as 0.5. So this is your 0.5. To find your next value, okay, the new value. So 0.5, put it in the rearranged equation. Okay, so here we want to find the x new, xi plus 1, which is the second iteration. So sine, the previous one is 0.5. Sine of square root 0.5. What you get? 0.64696. Huh? Yes, radian. Use radian. So you will get 0.6496. Remember, see the square root of 0.5. Sine in bracket square root 0.5. Not square root sine 0.5. Different things. Okay. Okay, so for the second iteration, you will get 0.6496. Try to proceed. Okay, wait, before that. How about the EA for the second iteration? Come again? 23, yes. How about the first one? No EA. Okay, because no old value, no previous value. Okay, try to proceed until you get the EA 0.01, lesser than 0.01. For the third iteration, you will need to find the xi value using 0.6496. Okay, so for the third one, I3, iteration 3, so sine this one, square root of 6496. Okay, try to proceed. Let's see how many iterations that you need to do. In from the beginning, this one is 1 point. The item should stop at 11. 11. Even you check your EA calculation. Okay, for those who had done the first exercise just now, try this question. Those who had done the previous one, try this one. Okay, before we proceed for this example, for the previous one, your final answer for XR (0.7686). So if you maintain from the beginning 4 decimal point, you will need to do iteration until 11 iteration. Okay, but if from the beginning you expand up to 5 to 6 decimal point, your iteration will be reduced. Okay, so as long as you get the XR at EA lesser than 0.01%, so you can stop already. Okay, so your XR is around this figure, 0.7686. Okay, the rest you should try to proceed until you get the EA later. Okay, so now I want to discuss example 2. Now we know that you must rearrange the X. Okay, we must rearrange the X. So actually the X here, you will have a few options. Okay, equation 1, most of you will rearrange straight away. This one, right? X equals to X power 2 minus 1. So from the original equation, you will rearrange to this. Let's say you rearrange to this. This is the easiest, the simplest, okay? But when you do, okay, that means here is X new, X old. Our starting point is 2. So when you do the iteration, first iteration, you will get 2. Second iteration, what will you get? Second iteration, 3. 3, right? What is your EA? Huh? 33%, remember, percent. Third iteration, what you get? Huh? 8. EA? 62. Supposedly, your EA should be reducing. Okay? When you see your EA increasing, then your equation is not correct to be used. Okay, so this one we call as BEP. EA is increasing, which is not correct. So your equation over here is not correct. If you can see, this equation, this quadratic equation, you can have a few options for x. Okay, so we try equation 2. Let's say you rearrange x2 equals to x plus 1. Can you get any more equation? Okay, equation 3, let me start from the beginning. Okay, for equation 3, let's say you rearrange into this. Okay, so you will get x, this one. Okay, so there are few options of x. So here, x power 2 equals to this, then x equals to what? X power plus 1 square root. Correct. Okay, for equation 2, try to do the iteration, whether you can get the EA reducing or not. Okay, this equation is either using this, or there are other options. Correct? Different. Equation 2, what you get for the first iteration is 2. Okay, the second iteration, what you get? 1.7. EA? 15%. EA is in modulus, regardless any sign. EA is positive. Okay, how about the third iteration? You get, Abbas, you get what? The rest? Same. Okay, check with Abbas. Third one, 1.65. 5, 5, 2. EA? 4, 4.7. Okay, looking good. How about the fourth iteration? 1.62. 88. EA? 1.5. Okay, so the EA here is looking good. It is reducing. Okay, so this equation is the correct equation to be used. Okay. Try to proceed until 6th iteration. What is your 6th iteration? 1.6. 1.609. 1.619. 1.619. The EA? 0.04. Okay, so the EA is decreasing. So this shows equation 2 is the correct equation to be used. Try to proceed with equation 3. What you get? One, right? EA? 100. See? Okay, third iteration? Error. So this equation 3 is also a bug. Okay, so if there are options of equation X, you should try until you see the EA is reducing. Okay, if you try the equation, the EA is increasing or you get error, then the equation that you use is not correct. Okay. Now, equation 2 can also be expanded as this. Okay, this is this equation is also correct to be used. You will get the same answer. How to get this? The x2 over x. Cut off, then you will get this. Over x side by side, both sides. Okay, how to know your answer is correct? How to know your answer is correct? You can get any value, but how to know your answer is correct? Check the answer scheme. If you don't have, okay, see the equation over here equals to 0. So the value that you get, plug in into the original equation. Do you get 0 or not? If you get 0, then your x is correct. Or you get 0.00 something. So approaching 0. So your answer is correct. If you don't get, let's say your answer you get equals to 2, then your x is not correct. Okay. Same as the previous example. Try to plug in back your final value into the equation. Do you get 0? The previous one is using 0.7686. So plug in back into the equation over here. You should be getting 0.00 something. So approaching 0. Okay. Any question on the fixed point iteration?
The x equals x plus 1 over x. I do the x equal to 1 with y. How would we be 1%?
If you do,
X equal to right. 2 plus 1 would be 3 over 2 would be 1 with y. But the answer is 1%.
wait, I don't get your question. If you put 2, if you plug in 1,
The second iteration. Yeah. So the
if you use for equation, I would say equation 4. This one. This one, equation 4. If you use this, your x new will be a bit different. X2 you will get 1.5. But at the 6th iteration, you will get 1.619 as well. Okay. Plug in back the equations, you will get equals to 0.00 something. Okay, so for this example, there are 2 possible equations of the x to be used. You must check the EA. It should be reducing. Okay. The true error, you must find using calculator. What is the x value? That one, the true value using calculator, not using the initial value. Yes. Can you get? No, right? Can you get or not? If using calculator, can you get the x from the calculator? That is your true value, is if you can get from the calculator. That is your true value. Wait, let me see previous question using fixed point iteration. Wait. Give me a few minutes. Okay, let's try this. This is from May 2022, final exam question. Can see not? Yeah, I make it larger. Okay, it gives you a small village in developing countries requires a spherical tank to hold water for the villagers. Okay, as an engineer, you are assigned to design the tank. The tank can hold a volume of water according to this equation, where V is the volume, H is the depth, R is the tank radius. Okay, using initial guess of this, compute the depth of the tank to hold 40 meter cube of water if R equals to 4. Okay, it asks you to compute the depth. Depth here is the H. Okay, compute the H. We focus on question A, 4 iterations of false position method. Sorry. Wrong question, sorry. This one is false position. We are looking for fixed iteration. This one you can try for your false position method. Sorry, my bad. You can try that question later. Sorry. Confused already. I want to find fixed iteration. Okay, this one. September 2022. Fixed iteration. Question 1. Where you are given function compute the root to 3 significant figures, okay, until 4 iteration. Here the question already gives you the stopping criterion. 4 iteration, okay, but using 3 significant figures, not decimal point, 3 significant figures. So with the approximate error EA and the value of function fx of each iteration. Initial value 1. So this is the equation that you need to use. Find using fixed point iteration. Okay, so now you need to, first thing first, what you need to do? Rearrange the equation into x equals to fx. Okay, try to rearrange and try to do until 4 iteration. Remember, if your EA is not reducing, then your equation is not correct. Can you snap the question first? I want to unshare the screen. You have copied the question, right? What you get for the final X? Until 4 iteration. 0, 1, 2. Check the blanket, check. Put back into Okay, the answer you might be getting around this range 0.751 or 0.722. Some of your friends get 0.722. You see not? So the equation, the correct equation is this one. This is the correct equation. Okay, so your final value x is around, should be around this figure. Some of you get 0.722. How to check? Check back the final answer that you get, put back into the equation, put back into the original equation. Okay? If you can get 0, then your answer is correct. If you get your answer 0.00 something, then that one is approaching 0. If you get 0.6, not close enough yet. Okay? Okay, snap the picture of this. I'll need to unshare and end our session because time's running up. Okay, this is for fixed point iteration. Next class, we will proceed to Newton-Raphson method. Okay, different approach. Okay? Okay, so that's all for today. If you have any question, we can continue in next class or you can always text me in the Teams.